Hello students. Today we are going to look into the topic on solid state, in which we are going to look at the general characteristics of solids and the classification of solids. Students, close your eyes and visualize around you. Think about all the things that comes to your mind. You will be seeing the wall, fan, tube light, tables, balls, pens, water inside the house, and the air that you are breathing, all these are different states of matter. Among the different states of matter, you will find that the solids are present the most. So today we are going to learn about all the characteristics of solid substances. In solids, the atoms or the molecules or the ions are tightly held in an orderly arrangement. So let us see in this lesson some more characteristics about solids. Matter may exist in three different physical states, namely solid, liquid, and gases. And also you find another state, the fourth state of matter, which is called as the plasma state. If you look around you, you may find mostly solids rather than liquids and gases. Solids differ from the liquids and gases by possessing definite volume and definite shape. The solids have the atoms being arranged in an orderly fashion. And there are many types of solids such as diamonds, metals, plastics, and many things around you. In a solid, the atoms or the molecules which are present are closely packed, as you see in the diagram. And they are regular, they are repeating patterns. They are held firmly in place, but they can vibrate within a limited area. What about liquids? In liquids, you will find that they have a characteristic of flowing easily. They have some force of attraction between them, and the liquids assume the shape of their container. What about gases? The molecules of a gas are so far apart that they can move freely, and the attractive force between the gas molecules are insignificant. In the plasma state of matter, at very high temperatures, atoms lose their electrons. The mixture of electrons and the nuclei that result is the plasma state of matter. Here are some examples of the fourth state of matter, that is of plasma: lightning, solar wind, welding arcs, stars including the sun, the earth's ionosphere, and the tail of the comet. These are all examples of forms of plasma. We have already learned in the 11th standard that gas molecules move randomly without exerting reasonable force on one another. This year, we are going to concentrate more about the solid state of matter, in which we are going to deal about the characteristics of solids, the classification of solids, what are the different structures of solids, properties of solids, what is a unit cell, the packing efficiency of the different type of cubic unit cells, crystal defects, and point effects. Let us pass on to the characteristics of solids. Solids have a definite volume and shape. The solids are rigid and incompressible, that is, they cannot be compressed easily. The solids have a strong cohesive force. The force of attraction between them is very strong because they are very close to each other. The interatomic or ionic or molecular distances in solids are very short, and the constituents, that is, it is made up of atoms or ions or molecules, these constituents have fixed position and they can only oscillate about their mean positions. Now let's see about the classification of solids. Solids are classified generally into two. One would be crystalline solids, and secondly, they are called as amorphous solids. Now, the crystalline solids are of different types. You can classify them as ionic crystals, covalent crystals, molecular crystals, metallic crystals, and atomic solids. The examples are given to you. For example, you see the sodium chloride salt that you take every day is an example for ionic crystal. And diamond and silica, SiO2, are examples of covalent crystals. In molecular crystals, examples will be anthracene, naphthalene, glucose, etc. Metallic crystals, all the metallic elements, example sodium, magnesium, gold, silver, all these form metallic crystals. And in atomic solids, the frozen elements of group 18 form atomic solids. Like helium, neon, argon, krypton and xenon, all the inert gases. Solids can be classified as either crystalline solids or amorphous solids. Quartz is a good example of crystalline solid. It is transparent. The term crystal comes from the Greek word crystallos, which means clear ice. This term was first applied to the transparent quartz stones, and then the name is used for solids bounded by many flat, symmetrical, arranged faces. A crystalline solid is one in which the constituents have an orderly arrangement extending over a long range. In contrast, in Greek, amorphous means no form. The constituents are arranged randomly. An example for amorphous solid would be rubber, plastic, glass, etc. Let us see some of the differences between crystalline solids and amorphous solids. Crystalline solids have a definite geometrical shape, whereas amorphous solids do not have a definite geometrical shape. Crystalline solids, they have a definite orderly arrangement in three-dimensional space, whereas the amorphous solids, they do not have an orderly arrangement of the constituents. In crystalline solids, they follow the long range order, whereas the amorphous solids, they follow the short range order. Crystalline solids have sharp melting points and boiling points, whereas amorphous solids do not have sharp melting and boiling points. Crystalline solids, the crystals are bound by plane phases, whereas no plane phases are present in amorphous solids. Crystalline solids have a particular characteristic called as anisotropy. They are said to be anisotropic, whereas amorphous solids, they are said to be isotropic. We will deal about this in the later classes. Crystalline solids are bound by unit cells, whereas in amorphous solids, they do not have unit cells. Lastly, let's say some of the examples of crystalline solids: the salt that you eat, the sweet sugar that you take, sulfur and many others, they form crystalline solids, whereas those which do not have a proper or arrangement of the atoms or the ions constitute the amorphous solids. Amorphous solids are also considered as pseudo-solids or supercooled liquids. And some of the examples of amorphous solids are rubber, plastic, glass, etc. Thank you.